So let's have a look at this question. So in the circle, O is the center. Okay, so here's O. This is the center of the circle. And the line AD, so remember when you have a line, it has 2 points. So this is point A, and then it's joined to the second point, which is point D. And they just write it like that, AD. So right now, AD, and it's read from left to right. So we have this line segment here, which is A to D. And it tells us that the line segment is a tangent. So tangent means if I have a circle like so, okay, it's a very bad circle, and if I have a tangent, that tangent touches the line at one point. Okay, so it touches the line at one point. And it touches the point, it touches the circle at this point here, point A. And so A is a tangent. The triangle AOB is an equilateral triangle. So the triangle AOB, so this is an equilateral triangle. Equilateral means that all the sides are of equal length, and you can see that they've put in a red line here to represent that on each one. So name two right angles in the figure. So two right angles in this figure. So when you have a tangent, okay, and then we have this center point here, and we have a parallel line. So this line is going to be parallel to the tangent. So if you take the center point of the circle and draw a line down to where the tangent touches the circle, you're going to create, that's a parallel line, and you're going to have two angles of that, which will be 90 degrees. So this one will be 90 and this one will be 90. So what we can say in this diagram here, we can say that the angle OAD is a right angle. So the angle OAD, that's going to be a right angle. So here to here, the right angle is here. We can also say that CAB is a right angle. So the angle, I'll just write like this, CAB is also a right angle as well. So again, this guy here, so this, let's say this whole piece in here, that would be a right angle. And then this angle in here is also a right angle as well. And that's the two that we've represented there. So the second one, this one here, it's a right angle. So again, if you have a circle, and if you split that circle in half, no matter where you draw a line, or if you take a point, you can put a point anywhere on this circumference here. And if you join the 2 points up to the end of the diagram, sorry, to either end of the diameter, you're always going to get this 90-degree angle. It doesn't matter where you put the point. Once you join the two lines here and here, that will always give you a 90. You're always going to get a 90-degree angle. So these two guys will be two right angle triangles, or right angles, should I say, in this figure. So the next one then is find the angle OAB. So we have the angle OAB. So we want to find out what this angle here is, OA. So OAB. So we want to try and figure out what the angle OAB, so OAB, so we're trying to figure out what this angle in here is. Now what we can say is, we know that this is an equilateral triangle. So we have, let me just do this. Okay, so we have an equilateral triangle. So that means the sides are equal in length, okay? But it also means that the angles are also equal in length. So remember, the three angles in a triangle have to add up to 180 degrees. And if all the angles in an equilateral triangle are equal, then one of the angles will be 180 divided by 3, which is equal to 180 divided by 3, which is equal to 60 degrees. So what we can say is that one of these angles in an equilateral triangle will be 60 degrees, and that's what this angle here is going to be. So this will be 60 degrees. So OAB, that's equal to a 60 degree angle. So that's that first one. The next one then is find the angle BAD. So BAD, so we're trying to find this guy in here. So let's color that in a bit there. So BAD, so we know that OAD has to be a 90 degree angle. So OAD, that has to be, OAD has to be a 90 degree angle. So what we can do is so if this is 90 degrees, the whole thing, these two angles together will be 90 degrees. We know that this one is 60, so therefore this angle here has to be what's remaining. So the angle BAD is going to be equal to 90 degrees, because this one and this one together form a 90 degree angle, minus the 60 degrees, which is equal, leaves you with 30 degrees. So the angle BAD is equal to 30 degrees. Okay, so that's that one. So this one is 30 degrees. And then the final one then, the angle CAO. So the angle CAO, so we're looking for this guy in here. So we've tried to figure out what that is. And we have these two here. Let's see. So this one, okay, so there's a little bit of working out in it. So we know that the length from here to here is equal, okay? So therefore, this length here from O to A will be equal to the length from O to C. So what that will mean is that this triangle here, so the triangle COA, that's going to be an isosceles triangle if the two sides are equal length. So what that means is that this angle, so this angle and this angle have to be equal to each other. Now what we can say also is that we can, if we can work out this angle in here, we can work out what that is. We can then figure out what these two guys here are. So what we can do in order to work that out is we can look at this angle in here, and remember this angle, so these three angles here are all equal to each other because this is an equilateral triangle. So what we can say from that is that this angle here is going to be 60 degrees. Now, if we look at this here, let's say from C to O to B, this forms a straight line. So it forms a straight line. So we'll just kind of do it the way that it was. Okay, so it's a straight line. We know that if we have a straight line angle is 180 degrees. Now what we can do is we can see that this is split up into two parts, like so. And this angle we know is part of this equilateral triangle, so it's 60 degrees. So now we want to work out what this here is. So we're trying to work out what this guy here is. Okay, and that's, so basically what that's going to be is, it's going to be 180 minus 60. So it's going to be 180 degrees minus 60 degrees, which is equal to 120 degrees. So we can say that this angle in here is 120. So it's 120 degrees. And then what we want to do then is, we want to work out, so we know that the three angles in a triangle have to add up to 180 degrees. Now, with this equilateral triangle, what we can say, we know that this is 120. So these two angles have to add up to the remainder. So we're going to have 180 degrees minus 120. and that's going to be equal to 60 degrees. And if we just call this, let's say we just call these angles x, refer to them as x. So we can say that two of the angles have to add up to 60, whatever the remainder. So it's 2x is going to be equal to 60 degrees. Therefore, x will be equal to, if we just want to get x on its own, we have to divide both sides by 2. And that will just leave us with, these will cancel out, and it'll be x is equal to 30 degrees. So what we can say then is that one of these angles, x is equal to 30 degrees. So therefore, this angle here has to be 30 degrees as well. So the angle CAO, which is this one here, has to be equal to 30 degrees. And that is it. We're done.